Okay, now we want to look at our classification techniques. And as a reminder, we've got a number we can work with. Here is a table that lists them all. And we have 6 that are considered two-class algorithms: logistic, averaged perceptron, decision forest, boosted decision tree, support vector machine, and neural network. 4 of those also have multi-class versions. So a two-class would be if you've got a binomial label value, yes, no, sick or well, fraudulent or not fraudulent. Multi-class, you're going to have a number of different classes that you could have. In our loan example, we had a number of different classifications for the current status of the loan status. Now, at the bottom of this table, we have 2 special ones that allow us to use the two-class algorithms even in a multi-class situation. So the one versus all multi-class, you apply a two-class method to it, and then it compares each class value, each possible value of the categorical attribute, label attribute, to all the other values. And it seems similar, but there's a distinct difference. The one versus one multi-class actually does a pairwise comparison of each classification value against each other classification value, and it continues on that way for every possible pairwise combination of classification values. So if you've got 4 classes, let's say you've got 4 regions, and those happen to be your label values, then it would compare the first one against the other 3. So there are 3 comparisons there. The second one against the remaining 2, 2 and 1. So 6 different comparisons versus the one versus all multi-classes would just have 4 comparisons, each class against the other 3 classes combined. All right. So let's work our way through them. You can read about them in the documentation and in the reading module. Let's work one out. We'll start our way with, let's begin with logistic regression. And don't let the name fool you. Logistic regression is actually a classification technique. All right, let's take a look at one other thing. Since we're now doing classification, we need a categorical variable to predict. So if we look at the insurance data set, I'll preview the data. And right now we've been predicting the amount of charges with our regression techniques. If we look at the profile of this data set, we can see that for charges, our median value is 93.68. Our mean is 13,000. All right, so in between there is about 10,000. So here we can see in our box plot the 5 numbers, again with the median. So 10,000. Let's see if we can figure out whether our predicted charges, whether a potential insured will be above or below the median value. All right. So by doing this, we'll create a new feature attribute in our data set that is a two-class label that we will use going forward. And we're going to do that by using the apply math operator. I'm sorry, the apply math operation pill. All right. So what I want is the apply math operation gives me a bunch of different categories that I can work with of operations that I can use. Here, I'm just going to do a basic comparison. So that is the category that includes, if it's greater than or if it's less than, here's what we'll do. So my comparison function will be greater than or equal to, and I'll make it a constant, and that constant will be 10,000. And I want it to check the column charges. All right. Output mode is append. So I'll change the node information so that we call this charges greater than 10,000. Or equal 10,000. There we go. All right. I'm going to leave the rest unconnected now. It'll probably break this run, but I want to get that math operation so I can know what that new column will be called. So I'll run a submit. No, it's going to make me run it. All right. So I'll go ahead and connect that and submit. And at this point, I should clone this and save this as a new experiment name, because this is going to be loan data classification examples. All right. Okay, so let's submit this, see what happens. All right, I broke the job because I'm not selecting a categorical variable for my logistic regression, but I was able to get the apply math operation to run. So let's preview that data. And I now have 8 columns, as you can see. So the new one is called greater than or equal to charges underscore $10,000. Wow. That is quite the column name. I'm going to definitely have to copy and paste that one. Okay, now I can go back in here and bring my newly enhanced data set into my split data. I'm going to train model. My label value now is going to be that greater than or equal to charges underscore $10,000. All right, let's save that. Everything else I can keep the same. I score the model, evaluate the model. Let's run it. Okay, we just finished up. Let's take a look at our score model and our evaluate model. All right, so our scored data set, here we can see our label value is true or false. Our actual scored label is true or false, and you can see it also calculates a probability. Logistic regression basically gives us a number between 0 and 1 that by default, I think we just round at 0.5 and say if it's above 0.5, true, if below, false. And that appears to be, based on a quick scan, the approach we're using here. All right. And you can see the distribution is kind of bimodal with larger values greatly towards one end or the other. Now, what that scored probability indicates in these that are really close to 1 or to 0, they're a lot more confident that that is false or that is true. False for 0, 1 for true. As we get closer to the center, let's see if I can find a score in here. Yeah, here's one that's 0.47412. So that's not too far away from being a 50-50 coin toss. But since it's slightly below, we guessed false. And as it turns out, we happen to be right in this case. All right. So now let's take a look at the evaluation results. And these look quite a bit different than what we were getting with our regression results. So the first thing I get is I get a rock curve. And one of the measures of that is how much area is underneath that curve. We call that the AUC, area under the curve, 0.983. So that means this is a pretty good model. And we also have a precision and recall curve again, and the lift curve. Again, the more dramatic the slopes are for these curves, the better the results. So we've got a 0.955 accuracy rate, 0.966 precision and recall. The F1 score is a nice sort of combination of precision and recall that is another good one number evaluation of a model. So typically for a classification model, the big three are accuracy, AUC, and then that F1 score. Accuracy really we don't like so much, but because it's so easy to explain to business users, we still use it. So AUC and F1 score are greatly preferred to accuracy. And then here we can see a confusion matrix. Since this is a two-class classification model, we have a 2x2 matrix here, and we can see the correct scores along the diagonal where we predicted a true value and actually got a true value. So those would be our true positives, our false positives, our false negatives, and our true negatives. All right, let's go back and take a look at our next algorithm.